We are now going to discuss about principles related to practical chemistry. Under this, we are going to talk about qualitative salt analysis. Qualitative salt analysis, this is the topic we are going to discuss. See, in this topic, we will be learning about how unknown salt can be identified, identification of unknown inorganic salt. The identification of unknown salt is done in 3 stages. There are 3 stages involved in the identification of unknown salt. I am going to put those 3 stages one by one. The first stage is, it involves preliminary tests. Second stage, we will be doing anion analysis, and in the third stage, at the final stage, we will be talking about cation analysis. So, 3 stages: preliminary test, analysis and cation analysis. So, let us start with preliminary test for the salt. Under this, number 1 in the list is physical state of the salt. Here, majority of salts are crystalline and very few are amorphous. So, here we need to answer this question whether the salt is crystalline or amorphous. Just remember that generally carbonates are amorphous. Carbonates are generally amorphous. So, if your salt is amorphous, then it is more likely that it is a carbonate salt, otherwise it can be other than carbonate salt. That is about physical state. Number 2 in the list is color. Certain salts, especially transition metal salts, exhibit characteristic color. So, from the color it is possible to identify the salt to a large extent. I am going to give you the list of salts with their colors in a tabular form. Well, this is the list of various salts with their colors. So, if your salt is blue, then there is a possibility that it could be a hydrated salt of copper or anhydrous salt of cobalt 2 plus. And if your salt is green, then it may be a salt of Cr3 plus, Ni2 plus, Fe2 plus. It may be cupric chloride or it may be cupric carbonate if it is green. And if it is yellow, it may be plumbous iodide, cadmium sulphide, or it may be some ferric salt. Ferric salts are lemon yellow in color. If your salt is pink in color, then it is more likely that it is a manganese salt, Mn2 plus. If your salt is red, then there is a possibility that it may be mercuric iodide or it may be mercuric sulphide in the form of cinnabar ore. If your salt is black, then it can be mercuric sulphide in the beta form, unlike mercuric sulphide in the cinnabar. This, if it is black, it is beta form of mercuric sulphide. Silver sulphide, copper sulphide, lead sulphide, nickel sulphide, bismuth sulphide, ferrous sulphide, cobalt sulphide, these are all black in color. So, color of salt gives an indication about the nature of salt. This is the tabular form you are supposed to know. Under preliminary test, the next one we are going to discuss is regarding solubility of various types of salts. So, we can sometimes get some idea about, some clue about the nature of salt from its solubility also. Let us look at it. Here we have to have a list of different types of salts with the solubility they exhibit. Number 1 is nitrate. Nitrate is NO3 minus, and remember that all are soluble. All nitrates are soluble. So, if your salt is soluble, if your salt is insoluble, do not consider it as a nitrate because all nitrates are soluble in water. Next, nitrites. Nitrite consists of NO2 minus. All are soluble. All nitrites are soluble except silver nitrite. Except silver nitrite, all nitrites are soluble in water. Number 3 is acetate, CH3CO minus. All are soluble except the only exception is silver acetate. All acetates are soluble except silver acetate. Number 4, chlorides. Chlorides are salts containing Cl minus. All are soluble except AgCl, Hg2Cl2, PbCl2. There are only 3 metal chlorides which are insoluble in water, namely silver chloride, mercurous chloride and plumbous chloride. And remember that plumbous chloride is soluble in hot water. It is insoluble in cold water. Number 5, bromides, Br minus. All are soluble except AgBr, Hg2Br2, these are the 4 bromides which are insoluble. All other bromides are soluble in water. Iodide, I minus. All are soluble except AgI, Hg2I2, Hgi2, Pbi2, Cui. These are the insoluble iodides. How many insoluble iodides are there? 5. Insoluble bromides are 4 in number. Insoluble chlorides are 3 in number. And what are the common cations present in these insoluble halides is Ag, mercurous and plumbous. These are the common cations. The extra iodides which are insoluble are cupric iodide and mercuric iodide. The extra bromide which is insoluble is mercuric bromide. Number 7. Number 7 is sulfates, SO4 2 minus. All are soluble except there are 3 sulfates which are insoluble: strontium sulfate, barium sulfate, lead sulfate. These are the insoluble sulfates. All other sulfates are soluble in water. Sulfides, all are insoluble except 1A sulfides. And also remember 2A sulfides dissolve slowly as hydrogen sulfides. They undergo hydrolysis and transform into hydrogen sulfides and slowly dissolve. So, excepting 1A and 2A sulfides, all other sulfides are insoluble in water. Number 9, carbonates. All are insoluble except 1A carbonates. Carbonates of 1A group, sodium, potassium, rubidium and cesium carbonates are soluble in water. All other carbonates are insoluble in water. Phosphates, PO4 3 minus, all are insoluble except 1A phosphates. So one thing we realize from this tabular form that most of the salts of almost all the salts of 1A group are soluble in water. Most of the sulfides are insoluble in water. These are the things we realize from the tabular form. All nitrates are soluble. Even all nitrides and acetates are also soluble except silver nitrite and silver acetate, which are slightly soluble in water. This is a very useful tabular form. It will be very useful throughout the inorganic chemistry, whether you do qualitative analysis, whether you do S block, P block or D block elements. This tabular form will be very useful in deciding especially precipitation reactions. You know, in a precipitation reaction, the simple logic is a more soluble salt will give a less soluble salt. More soluble salt will give less soluble salt. So it's very, very important to have an idea about solubility of salt so that you can decide the feasibility of a reaction. The reaction will be feasible, precipitation reaction will be feasible in the direction in which, you know, a more soluble salt will transform itself into a less soluble salt. The next preliminary test we are going to discuss is flame test. In the flame test, we take a small pinch of salt and on a platinum loop and expose it to the Bunsen flame, and we get a characteristic color on the Bunsen flame. Based on the color, we can identify the cation. I am going to give the list of flame color and the cation present in the salt, right. So I will write it as flame color and the cation present. If the flame color is bluish green, then it's an indication that the salt must be some cupric salt. If the flame color is, it consists of green flashes, it can be Mn2 plus or Zn2 plus salt. If it is golden yellow, then it is sodium salt. If it is crimson red, it must be lithium salt. If it is lilac, it must be potassium salt. If it is blue, cesium salt. If it is ruby red, it must be rubidium salt. If it is brick red, it must be calcium salt. If it is crimson, strontium. If it is apple green, it must be then barium salt. So this is the list of various flame colors with the cation present in the salt. So if your salt is giving apple green color to the Bunsen flame, it must be some barium salt. Then we need to do confirmation test for barium and confirm its presence. The next preliminary test we are going to discuss is borax bead test. I'll explain you about borax bead test. First we'll talk about the various types of colors you get in borax bead test, and after this I'll show you what are the reactions involved in the borax bead test. See, the first column I have made is color of bead, and in this you have two parts, oxidizing flame, reducing flame. On the other side you have cations present in the salt. Now if your salt exhibits blue color, it forms blue colored bead in the oxidizing flame, and it becomes opaque red in the reducing flame, then your salt must be copper salt. If it is green in both oxidizing and reducing flame, then it must be Cr3 plus. If it is blue, if it is forming blue bead in both oxidizing and reducing flame, the bead is blue in color, then it must be cobalt. If it is lemon yellow in the oxidizing flame and green in the reducing flame, then it must be iron salt. If it is pink in the oxidizing flame and colorless in the reducing flame, then it must be Mn2 plus salt. If it is brown in the oxidizing flame and gray in the reducing flame, then it must be Ni2 plus salt. Well, this is the list of various cations with the different types of colors, colored beads they form under different conditions during the test. Now, I am going to show you what is the reaction which is involved in the formation of colored bead. See, borax is, I will just close this. Borax is Na2B4O7. When heated, it breaks up into NaBO2 and B2O3. B2O3 is called as boric oxide. This is sodium metaborate. These two form a transparent glassy bead. Now, B2O3 plus some metal salt, when they are heated together, then you get metal metaborate. Metal salt, when it is heated, becomes metal oxide, which is basic, and it will react with acidic boric oxide and forms a salt, metal metaborate. The color of the bead is due to the color of the metal metaborate. Remember, this is the substance which is responsible for formation of colored bead. Now, remember that borax bead test is given by transition metal salts having cations with a D1 to D10, D1 to D9 configuration. D0 and D10 metals, their beads are colorless, like zinc will form colorless bead, cadmium, mercury, they form colorless beads, scandium 3 plus, yttrium 3 plus, lanthanum 3 plus, they also form colorless beads. So, D0 and D10 metals form colorless beads. Colored beads are formed from D1 to D9 configuration. Apart from this, S block and P block metals also do not give colored bead. So, colored bead is not given by S block metals, colored bead is not given by P block metals, colored bead is not given by D block metals whose configuration is either D0 or D10. D1 to D9, these metals can give characteristic colored beads. Some of the examples are given in the tabular form. Go through these examples. That is borax bead test. In the borax bead test, borax is heated. You get a mixture of sodium metaborate and B2O3, which is a transparent glassy bead. This consists of an acidic oxide. When heated with a transition metal salt, during heating the metal salt transforms into metal oxide, which is a basic oxide. Acid base reaction takes place between B2O3 and the metal oxide to give metal metaborate, which is forming a colored bead. Now, color depends upon whether you expose it to the oxidizing flame or reducing flame, because if a metal is able to oscillate between two different oxidation states, like for example, Fe has two significant oxidation states just differing by 1 unit, ferrous and ferric. So, it oscillates from ferric to ferrous. When you go into oxidizing flame, it becomes ferric, therefore lemon yellow. When it comes to reducing flame, it becomes ferrous and appears green. Whereas cobalt, the significant oxidation states of cobalt differ largely in their energies, therefore it continues to remain blue in both oxidizing flame as well as reducing flame.